Different companies can come up with different figures for a heat loss survey for a variety of reasons, different experience levels across the person carrying out the survey, how interested that surveyor is in actually getting an accurate figure, how much of a rush they're in, and also the software they're using. Now, that's an interesting one. This is Heat Punk, my favorite, or it now uses the most up-to-date British standard for heat loss surveys, which is a 2017 standard. But up until last year, that wasn't mandated for MCS installations. You could use the old 2003 standard, a much simpler standard, and it handles heat losses and air change rates throughout the property very differently. And the older method will demand a larger heat pump because it assumes all the air changes throughout every room all happen at the same time. And that's not technically possible because the wind around your house does not hit all sides evenly at the same time. So the air changes from room to room are not as calculated in the 2003 method. So these two properties are mapped out in exactly the same way. Same sizes, same materials, same U values, same internal temperatures. You'll see 21 degrees and an air change of 1.5 per hour. And that's exactly the same as I've got in Heat Punk. So you can see here 21 degrees inside temperature, 1.5 air changes per hour. And this one is showing 4,866 watts total heat loss for the same size property. So 4,866. And for this exact same property, this is coming out at 7,815 watts. That's quite a difference. And it's the default modes for the softwares that can make a difference. And if someone isn't as geeky as we are, then perhaps they don't understand the differences between the two. And if you have a property where your heat loss figure done with this older method puts you into what's called a twin fan category, you may end up having it suggested to you that you have a heat pump that has two fans stacked on top of each other. And in some cases, that'll mean you can't have it installed at all in your property because you may have nowhere available for a twin fan unit to go. And the only places you have for a heat pump are underneath a ground floor window. And the twin fan units stand somewhere around 1.7 meters tall. And that will obviously cover a ground floor window. And the sound power levels from a heat pump with twin fans is greater than that of a single fan. So you want to be careful of which methods they're using. And that's a big reason why they can come out differently. And you'll see, I'll go back to this one. It's 4866. I'll go back to the legacy method. And this is coming out at 7718. So quite a big difference. But if we use the current standards and we go to the standard method, again, you'll see here, that's back down to 4.8 kilowatts or 4,866 watts. Another reason could be the internal room temperature design between different companies. Some companies like to use 21 degrees everywhere as a standard, not technically to MCS design criteria or SIBC design criteria that has 22 degrees as a recommendation for bathrooms, 18 for hallways, but it all depends on the year your property is built. Also, if your surveyor doesn't know that, then that can affect your heat loss calculation. So compare apples to apples. Another thing that can affect it is the design temperature. Not everyone uses the same design temperature. We have two choices, what's called the 99.6 percentile column and the 99% column, and you'll see they're different. We designed to the 99.6 because we would rather design a system that can heat your home in those colder months, but a lot of companies don't. They will choose the 99% to try and give you as fewer radiator changes as possible, which is understandable because there are plenty of examples where radiators are perfectly adequate as they are. But that's just another reason why they can differ. And like I say, we've got indoor temperatures based on CIBSE, and that's determined by the property age as well. So an earlier property that hasn't had any recent renovations will have the older 18 degrees for bedrooms, kitchens, 21 for living areas, for example. But you pop in post 2006 for a slightly newer build, or if something's had a renovation since then you can use 21 degrees everywhere and 22 in bathrooms as a starting point. Just more things that make the differences highlighted between different companies. Also, the software you use is very important. So we'll come back to the design stage. So for lots of properties, a simple flat ceiling is what we have. But in plenty of properties we go to, you'll have a property with a room that has a vaulted ceiling. And vaulted ceilings are often just a simple vaulted ceiling like this, where we have a very high section in the middle, and then that drops back down to a standard room height. And you can see the arrow that's indicating the direction that is heading in. I'll do the same on the other side quickly. And this is important because it will change the volume of the room. And if you can't accurately map vaulted areas, you can't accurately map the volume of the room. So you can't then accurately map the heat loss of the room. So vaulted areas are really important, and this is where heat pump shines. Most softwares can do a simple vault like that, no problem. So if I head back into this one and we go and say the ceiling is a roof and it is vaulted, we'll change this on the right hand side. You can see down here I'm adjusting this, and you can say, okay, these are the different vaulted types. Well, we're going to stick with this one, and we're going to say, yep, that's the same as one, 4.5 meters there. We'll do the same on this side. Here's one I did earlier, and that changes the volume of the room. So now we'll go back, and we have now 10,700. So if someone had actually entirely forgotten to put the vaulted ceiling in, huge difference from 7 point something kilowatts up to 10.7 kilowatts, because the meters cubed, the volumetric measurement of that room is completely different. But now we'll compare it to the heat pump version. And with the more modern heat loss standards, you can see this is sitting at 6.3 kilowatts, vastly different from 10.7 kilowatts with the older method. That's not to say people can't adjust it, but these are the defaults. So if someone's not detail orientated, this will be why you get such wildly varied heat loss reports from different companies. And then we get to the stage where you need a more complex vaulted ceiling, which is not uncommon at all, where the ends, the gable ends, fold in. And I'll do the same at this end. I think barn conversion or something like that. So now we tell it the height at this end and the height up here, height as well, and now we see all 4 arrows are pointing in the right direction. And we'll now look at each room's cubic volume. So it's about 321, give or take. So pretty accurate, but 321, I can't do that same level of detail in this software. There is no way of having those gabled ends lent in so we can't accurately map the volume of that. All I can do is the best I can with the tools at hand. So if your installer is using a piece of software that doesn't allow that level of detail, and you have vaulted ceilings that aren't just basic vaulted ceilings, or ceilings of different heights, often people just try and average it out. So we have to go to the report for this one, and heat loss by room. We can see the volumes here: 345 meters cubed versus the actual 321. And if you have a property with multiple vaulted ceilings or ceilings of different heights, that can all add up very quickly and artificially increase the heat load requirements of your property. So different companies use different softwares, have different engineers, and it all depends on the software you're using and the attention to detail for the engineer surveying the property. Also knowing and paying attention to the correct materials. So different walls can have different materials. You can have, for a new build, these values all inputted default on both programs, but your surveyor needs to be able to tell the difference between a solid wall, a header and a stretcher brick wall, and the different surface finishes. All these things make a difference, and the more detail orientated your surveyor is, the more accurate the sizing of your heat pump and each room by room's emitters can be. Many factors, and experience and knowledge goes a long way. And to add confusion to it, I see people talking and asking questions that so-and-so company has told me I've got a 10 kilowatt heat loss, but they've recommended a 12 kilowatt heat pump. Isn't that overkill? Won't I get cycling issues? And good questions, but the naming conventions around heat pumps are confusing, because a 12 kilowatt heat pump doesn't necessarily put out 12 kilowatts of heat at your design outside temperature. They're often rated or named based on their outputs at an average outside temperature for an average climate, which is somewhere around 7 to 10 degrees air temperature. And that's what they'll be showing their output at as a 35-degree flow. As soon as that outside temperature drops to your actual design temperature, so -3, the outputs of those units do drop as well. So a heat pump named as 12 kilowatts may actually only put out 9 or 10 kilowatts when it's -3 outside. So don't let the naming conventions put you off too much or confuse you too much. They're confusing for a lot of people in the industry too. But once you start digging into the actual nominal outputs at different outside temperatures and various flow temperatures, then it starts to make a bit more sense. I hope that makes heat loss surveys and why they can be different across different companies and platforms a little clearer to you. And if you have any questions, feel free to ask.